Self-recovery prompting. Promptable general-purpose service robot system with foundation models in self-recovery. Hello, I'm Mimo Shirasaka from the University of Tokyo. Targeting household service robots. In this research, we analyzed failure cases in robot task execution based on diverse language instructions and developed a system that continuously attempts to improve performance until the requested task is completed. This research focuses on the realization of a general-purpose service robot. The concept of a general-purpose service robot, or GPSR, entails a robot that can execute tasks in a versatile manner to meet various human requests that may arise in daily life. The given command is,
I'll start studying at my desk in a moment, so could you get a bottle of tea from the side table and leave it on my desk?
Then the robot performs as asked. It goes to the side table, finds the bottle of tea, picks it up, goes to the desk, and places it on the desk. Everyday conversations can include information irrelevant to task executions or lack necessary information. Moreover, in dynamic environments where people and objects can move, the environment changes rapidly, leading to uncertainty in the information. Therefore, to carry objects, store items, or provide customer service in a household environment, it is necessary for the robot to accurately extract the required information from the given command, notice missing information, and supplement it. In unexpected situations, the robots need to have reasoning abilities to execute tasks. Having a service robot stopping in the middle of a room being confused is what we wouldn't want. What we want is a robot that is robust enough to recover failures and accomplishes the asked task. Our conventional GPSR system would terminate attempts upon task failure. Therefore, in this study, after analyzing failure modes, we incorporated prompt updates of large language models into our multimodal foundation model-based system. This enabled us to construct a robot system capable of recovering from failure without leaving tasks unaddressed. We categorized failures in GPSR into 3 failure modes. Mode 1, insufficient information. Mode 2, incorrect plan generation. And Mode 3, plan execution failure. To realize the GPSR system, we implemented a foundation model-based system. The 4 models enclosed in red frames are used in our research system. Visual information is useful for finding objects and grasping them. We use the open vocabulary detic and clip for object recognition. Specifically, we perform segmentation of the detected objects using detic on images obtained from the robot and classify each segmented object using clip. In terms of the overall process, we use Whisper to transcribe requests made by humans through verbal commands like "bring me a ball." We then use the large language model GPT-4 for planning, which involves determining the sequence of actions the robot should take. All of these foundation models can be easily adapted to the environment through prompt updates without fine-tuning. To address the failure modes, we introduce self-recovery prompting. Iterating through prompt updates and replanning or human-robot interaction enhances service performance. In concrete, for the commands such as pick an apple end, for failure mode 1 like no sufficient information on apple's location, the robot asks a human or LLM. For mode 2, like getting negative feedback for the overall performance, the sequence of human-robot interaction, prompt updates, and replanning solves the failure. Finally, for failure mode 3, like failing to grasp the apple, the system seeks prompt updates, replanning, and human-robot interaction. Note that our system is promptable, so that it can recover from failures reflecting the status with prompt updates. Experiments were conducted to examine the system's ability to recover from each of the failure modes. We evaluated the entire system using 7 handcrafted commands and confirmed that our self-recovery prompting mechanism successfully resolved failures for all tested commands. Here are the examples. As given the command,
"Could you help me find the apple that I bought the other day?" Ashley might know where it is, so maybe you can ask her if she knows where it is. When you find it, please bring it to me.
the robot needs to know the apple's location, but the human doesn't know. Then our system infers it could be on the dining table and successfully finds the apple. In this case, the command is given, but the robot cannot understand it.
Could you bring me the apple from this direction?
I am afraid I don't know how I can help you. So, please give me instructions in the order I should perform.
So we ask the human to rephrase the command, and then finally understands it. Lastly, in this case, the command is given,
Could you look for Ashley in the dining room and ask her if she wants dinner at home tonight?
but the robot cannot find a person named Ashley at the instructed place. Then our system replans the next moves to explore another room and successfully finds Ashley. In conclusion, in this work, we organized 3 failure modes in realistic GPSR applications and proposed a self-recovery prompting pipeline to overcome the 3 failures. Thank you for listening.